Hi, in this video we're going to learn about radical expressions and rational exponents. At the end of the video, you should be able to simplify radical expressions. Let's begin with your basic concepts. Finding a root of a number is the inverse operation of raising a number to a power. In your expression, this symbol here you see is called the radical sign. In the given expression, the expression under the radical sign, which is a, is called the radicand. The index defines the root to be taken. It could be that your expression represents a positive or principal root. It is also possible that you have a negative root of a number. A square root of any positive number has two roots. One is positive and the other is negative. If a is positive number, then square root of a is the positive square root of a. And the other expression is the negative square root of a. Example, square root of 100 is 10. Negative square root of 36, you take the negative root, and so you have negative 6. Square root of x to the power of 8, you apply your rule that you learned, power over root. Power is 8. Root is 2 because that's the index here. 8 over 2 is 4, so the expression is equal to x raised to 4. If you have a fraction, you just separate the top and below, or you just get the square root of the number on top and the number below. Square root of 25 is 5, square root of 49 is 7. It's 5 over 7. Sometimes you have decimals. You have square root of 0.81 is actually 0.9, because 0.9 times 0.9 is 0.81, just like 10 times 10 is 100. Square root of a negative 9 is actually not possible. There is no way that when you multiply, the result gives you a negative 9. Therefore, square root of negative 9 is non-real number. How about cubes? A cube root of any positive number is positive, although there is also a case of negative. A cube root of any negative number is negative. Let's have an example. You have cube root of 27 is actually 3, because 3 times 3 is 9, 9 times 3 is 27. Cube root of negative 8 is actually possible because it is actually negative 2. When you check, negative 2 times negative 2 is positive 4. Positive 4 times negative 2 will give you negative 8. That is the second case. If you have a fraction form, cube root of 125 is 5, 64 is 4, 5 over 4. Power over root, cube root is opposite of cube. That's the other way to look at it. Or power over root, 3 over 3 is 1, so x. 12 over 3 is 4, so you have x to the power of 4. Here is your power table in case you need an easy way of checking if there exists a specific root given a number raised to this power. See how it will be helpful. Like for example, 256 has a fourth root of 4. 216 has a cube root of 6. This will come in handy if you encounter a number you're not sure of, if it has a root or not. Now, higher than 3, you have nth root, power of root of 4th root, 5th root, 6th root, and onward. An nth root of any number a is a number whose nth power is a. So you have 3 to the power of 4 is actually 81. Therefore, 4th root of 81 is equal to 3. Just to show the relationship of exponential form and radical form. If you have 2 to the power of 4, 2 times 2, 4, 4 times 2, 8, 8 times 2, 16. 4th root of 16 is 2. You can always refer to your power table. Negative 2 to the power of 5 is negative 32. 5th root of negative 32, therefore, is negative 2. Okay, there is one more thing you need to observe. Negative 1, 5th root of negative 1 is actually negative 1 because it will work. Negative 1 times negative 1 times negative 1, negative 1, negative 1 is actually a negative 1. Therefore, it's true. If you multiply negative 1 5 times to itself, the result is negative 1. What if you have 4th root of negative 16? Is it possible? Actually, no. If a number multiplied to itself, if a negative number multiplied to itself 2 times, 4 times, 6 times, you will not have a negative result. Therefore, this is not possible. Even if you have a power of 6, negative 1 to the power of 6 is not going to be negative 1. So, it's not possible. But if you have 3, cube root of negative 27 is actually possible, which is negative 3. Because when you multiply negative 3 to itself, 3 times, it gives you negative 27. What you need to observe is that for some perfect number, perfect power of n, negative, it only works for odd numbers. Even numbers, not possible. It's just not. Okay? You can always use your calculator to check the root of a given negative number. By definition, you have power over root a raised to m over n is written as a to it's written as nth root of a to the power of m, or the other way around, nth root of a to the power of m. The expression nth root of a has a power of m. Either of these will be helpful. It depends to the problem. Only one can work, or maybe both. Let's have an example. The value of a number represents the power of the radicand. The value of the denominator represents the index or root of the expression. Here is your example. 25 to the power 1/2 can be rewritten as power over root. So 25 has a power of 1 but root of 2. So it's actually square root of 25. Square root of 25 is possible to simplify. It's actually 5. So the expression was simplified by applying our definition. Another example, 27 to the power 1/3. It's actually cube root of 27. But 27 is a perfect cube number. Therefore, it has a root. And its root is 3. Therefore, cube root of 27 is 3. 4 to the power of 3/2 means you have square root of 4 to the power of 3. 4 to the power of 3 is actually 64. 64 is a perfect square. Other than it is a perfect cube, it's also a perfect square. And the square root of 64 is actually 8. Another example, if you have the expression raised to a fraction exponent, remember power over root, so it's actually 7th root. The whole expression is a 7th root to the power of 2. 2x plus 1 to the power of 2, but the whole thing is 7th root because power over root. Let's proceed. This is now your first property that you can use when you simplify your rational expression. By definition, if square root of a and square root of b are real numbers, then you have square root of a times b. You can actually factor it as square root of a times square root of b. This is factoring. That's why it's product rule. Example, 40 has a factor of 4 times 10. Why did we factor 4 times 10 and not 8 times 5? 8 times 8 and 5 are neither perfect number, but 4 is a perfect square. We can separate by property, and so we can simplify 4 square root. It's actually 2. So we have 2 times the square root of 10, and that's the simplified form, and that's it. Another example. Just refer to your table, 75, and look at your power of 2. You don't see 75, but what you could use is find the number that you can factor out 75 on the power of 2, which is 25. 25 times 3. Why did we choose 25? Because it's on the power of 2 row column, because 25 is a perfect square number, and so it has a square root. The square root is 5. And so it was split here by definition, and square root of 25 is 5, so you can now multiply 7 times 5 is 35. And that's your answer. Another example. Square root of 16 times x to the power of 17. This is a little tricky. 16 is a perfect square. Power of 17, you have to work it out, wherein you could actually factor it. Remember, when you multiply exponents, actually you just add the exponent. So when you factor, you actually separate, wherein when you add, it gives you that number. So therefore, to make this possible to simplify by square root, you can have 16 plus 1. Let me see how it works. So when you separate, when you multiply this back, 16 plus 1 is 17. We separated it because it can be simplified. You have square root of 16. We're trying to apply the property, times square root of x to the power of 16 times the square root of x. We are separating it so it's clearly shown how it was simplified. Square root of 16 is 4. This second expression is actually power over root. 16 is power, root is 2, 16 divided by 2 is 4. It's actually x to the power of 4. No, 8, sorry. 16 over 2 is 8, and so that's x8. And then the last term, you cannot simplify it, and so it's left as is. And we were able to simplify the expression applying your product rule, which is factoring your expression inside. Let's have another example. This time it's cube. So how do we begin? We actually factor 16. Looking at your cube table, you find 8. 8 is a perfect cube number, and you multiply 8 times 2, which is actually a factor of 16. 17, you take out 2, separate 2, because 15 is divisible by 3. So that when you apply your factoring, you separate 8, cube root of 8, cube root of x15, and then the non-factorable is left together in one cube root, the 2x squared. That will not be simplified further. Only the cube root of 8 is 2 is simplified, and then the second one, power over root 15 divided by 3 is 5, is x5, and the remaining is left unchanged because it's not possible to simplify. And that's how you simplify rational expression by product rule. This should be the most helpful page or the most helpful part when you have your exercises. There's another rule. It's called quotient rule. According to the definition, if square root of a and square root of b are real numbers, then square root of a over b you can actually separate them. Square root of a divided by square root of b. How do you apply the property? So if you have square root of the expression 16 over 81, you can just separate them. Square root of 16 over square root of 81. Square root of 16 is 4. Square root of 9 is 81. That's the quotient rule, if in case you encounter square root of a fraction. Another example, square root of the expression 2 over 25. You just separate on top and below. Square root of 2 does not simplify, but the square root of 25 does. It's 5. So that's your final answer, square root of 2 over 25. Here, 45 is not a perfect square. So what do? Look at your square numbers and which one factors 45. It's actually 9 times 2. You separate it first and then 9 times 2. No, 9 times 5, sorry. Square root of 9 can be separated into, or can be simplified as, let me go back. Square root of 9 is 3. Square root of 5 does not simplify. Square root of 49 is 7. And that's your final answer. Okay, so there are two properties or rule that you can apply: the factoring, the product rule, which is factoring, and the quotient rule, which means you can split a fraction, a square root on top and a square root below. Here are more of the examples. See how it will help you with your problems. Square root of x raised to 11, you just separate or factor it out with x10 and x1 because 10 plus 1 is 11. Wherein square root of x10 is actually x to the power of 5. Square root of x does not simplify. Remember, there's 2 here. The 5 came from 10 divided by 2. Next, square root of 18 times x to the power of 4. 18 is not a perfect square, but you can factor it out by 9 times 2. Square root of 9 is 3. Square root of x4, 4 over 2 is x squared. So you have 3x squared and then 2 is left unchanged as square root of 2. Again, square root of 9 is 3. X to the power of 4 has a square root of x squared. Square root of 2 does not change. That's it. Next, by quotient rule, we will separate, and then 27 is not a perfect square, but we can factor it into 3 times 9 or 9 times 3. x8 does simplify. 8 over 2 is 4. Square root of 9 is 3. Square root of 3 is not possible to simplify. Square root of x to the power of 8 is x4. So that's your answer. Next, by quotient rule, we will separate them. Square root of 7 does not change. Separating 7 into splitting, factoring it into y6 and y1. y6 becomes y cubed after simplifying it with power over rule. 6 divided by 2 is 3. Square root of 25 is 5. Only the y to the power of 6 is simplified into y cubed. The rest on top is left unchanged, 7y. Square root of 25 is 5. Another example, 88 can be factored into 8 times 11. 8 is found on the cube table, which is 2. 8 has a cube root of 2. 11 stays as cube root. Here you just split. See how it goes. Cube root of 10 over cube root of 27. We can actually factor 10 into cube root of 2 and cube root of 5. It will make sense. No, it did not. So you have only cube root of 27 and that's it. Since cube root of 10 does not simplify, it's left unchanged. You have cube root of 27 times m cubed times n to the power of 7. 27 has a cube root of 3. N cube has a cube root which is m. This one becomes m. N6 becomes n squared because 6 divided by 3 is 2. N6 times n came from the factor of n7. So you have m, n squared, and then cube root of n is left inside. So you have 3 times m because it cancels out, 3 over 3. 6 over 2 is 2. And then the last n is left unchanged. Here you have cube root of 81 over cube root of 8. 81 is factored into 27 times 3. Cube root of 8 is 2. Cube root of 27 is 3. Square root of 3 is left unchanged. Okay, I guess we are on our very last example. Fifth root of 64 times x12 times y4 times z18th. 64 is not a perfect fifth root, but actually we can factor it out. Looking at your power of 5 table, you have 32. 32 times 2. x10 came from the factor of x12 by separating 12 into 10 plus 2. y4 is unchanged because it does not simplify with the fifth root, but 18 does, which is 15 plus 3, because 15 is divisible by 5. So what happens here? 32 has a fifth root of 2. x10 has a fifth root of 2 because 10 divided by 5 is 2. z15 is actually 15 divided by 5 is 3. And these are the ones that are not simplified. And they are left inside the fifth root. The rest are simplified into 2x squared z cubed, because by power over root. And that's it. At the end of the video, you should have learned how to simplify radical expression. You can always watch the video again so you are able to best answer your exercises. Thank you.